So thus far we've talked about how you can add vectors using the tip-to-tail method. And that's a great way to conceptualize vector addition and what the results should look like. However, if you want to get exact numbers, using this method is kind of hard because your calculation is only going to be as accurate as the picture that you draw. Unless you use a ruler and a protractor and are very, very careful with your drawing, the resultant vector that you end up with will probably not have exactly the right length. And these very accurate drawings could be very time-consuming. So for actual calculations, what we will be doing more often is to break the vectors into components. And this method is faster and more accurate. So the method of breaking it into components means that first we have to choose a convenient coordinate system, and we take each one of our vectors individually and put the vector tail at the origin. Once we do that, we can see that part of the vector is in the x direction, part of the vector is in the y direction, and we find the lengths of these vector components. Then once we have the lengths of the components, we can add the components together in order to find our resultant vector. So to reiterate, we first will break our vectors into component vectors, which are parallel to the x and the y axes, and then we can add together those parallel components. So for example, in this picture, we're adding together vector A and vector B. So we would first find the x and y components of A, and then also the x and y components of B. Then since the x components of both A and B are in the same direction, the x direction, we can add those together. And the sum will give us the x component of the resultant vector. Then we do the same thing for the y components. We add together the y component of A plus the y component of B, and the sum of those two will give us the y component of the resultant vector. Then once we have the resultant vectors x component and y component, we can use the Pythagorean theorem to find the magnitude of the vector, the length of the resultant vector, and also the angle that it makes with, in this case, the positive x-axis. So let's take a look at an app where we can practice adding vectors. And this vector addition app is linked from Learning Hub. So you can go to the class page on Learning Hub and download this vector addition app. So with this app, we can add vectors. I can grab a vector and place it so that its tail is at the origin. So maybe something like that. And then I can grab a second vector that I want to add to the first. And you can see when I select either of the two vectors, at the top of the page I'm given the length of the vector, the angle it makes with the x-axis, and also its x and y components. Now I can show the sum of adding these two vectors together, and if I move this vector, because remember, vectors, only the length and the direction matter. You can slide them all around and they're still the same vector. But I can line the sum up so that its tail matches the tail of the first vector, its tip matches the tip of the second vector, and you can see that this is my vector sum. And at the top of the page, we're given the length, the angle, and the components. Now right now I can't see the components, but I can turn on some different component displays. So there's one style of showing the components. So here you can see the pink arrows represent the x and y components of the first vector, the x and y components of the second, and when I add together the x components of the first and second vectors, I get the x component of the resultant, and the same with the y components. They add up to give the y component of the resultant. Now if I choose style 2, I can see this a little bit more clearly. So this looks like the picture we had on the slide, where the x component, if I add them together, they will sum to the x component of the resultant, and the same with the y. And with style 3, I can move the components around yet again and see very clearly how the x components of the two individual vectors add up to give the x component of the resultant, and the same with the y components. So here's a question for you. Let's say that vector A lies in the xy plane, and we put the tail of vector A at the origin. In which quadrant would the tip of vector A lie if both of its components were to be negative?